Thank you. Hi team, here our week 9 update for the Hepatitis C virus detection model project. This past week, we worked on fine-tuning our assembled model with the ABC algorithm and tested it using five-fold cross-validation to ensure accurate detection, especially for the minority classes. And also, we focused on confirming that all features contribute effectively to the model. So I'll start with my update and then we will go around with you guys. So what we have done until so far, the first step was data preprocessing. So to ensure a solid foundation, we slowly preprocess the data set by addressing missing value in the numerical features, replacing them with the mean values. This allows us to avoid any data loss and provided a complete data set for our analysis. We standardized all numerical features with a min-max scaling, keeping values within the same range and aiding our models in interpreting the data effectively. And also we label encoded categorical data like a sex, column and map target values like a blood donor and hepatitis and etc. to unique integer like numbers, ensuring consistency for model interpretation. And this pre-processing prepared the data for effective training with a minimal biases or noises.
Thank you, Samana. May I talk about building our model and our initial steps?
Yes, sure. Right.
Thank you. So, I want to talk about our initial steps and just how I'll build our model. We created two primary models, which is the first one is random forest and logistic regression. The second one. Random forest was applied to the raw data set to focus on effectively identifying majority classes like blood donor, while logistic regression was trained on a balanced data set using SMO to improve detection of minority classes like cirrhosis and hepatitis. So to refine feature relevance, we employed recursive feature elimination, returning all 12 features which enabled the model to leverage complete information for classifications. Additionally, we set up the artificial V-cloning ABC algorithm to blend these models, random forest and logistic regression, blending them into an optimized assemble. Dynamically balancing random forest and logistic regression for improved performance.
Thank you, Mike.
Guys, if you are okay, I will speak about the last step.
Thank you.
Okay.
Sure. The last step is initial optimization with ABC algorithm. So the next step was using the ABC algorithm. As you know, we fine-tuned our assemble model by finding the optimal blending parameter alpha, which balances the contribution of random forest and logistic regression. After initializing with a population of potential alpha values, we iterate through around 7,000 cycles to maximize model accuracy. This approach improved classification performance, particularly in accurately identifying the blood donor class. Though minority classes like hepatite and suspect blood donor remain challenging. We will continue to refine the model to reduce misclassification rates for these critical classes.
Thank you, Mahmoud and Mariam. And as you know, guys, we have some challenges and problems during this project. One of our main challenges about dealing with the class imbalancing. Blood donor classes significantly outnumbered the minority classes like cirrhosis and hepatitis. So this leading our models to favor majority classes while underperforming with the minority classes like hepatitis and cirrhosis. despite high accuracy for the majority classes, like suspect blood donor, random forest missed many true positive for minority classes like hypothesis. So it's leading to lower recall. This was particularly problematic for our goal to early HCV detection, which relies heavily on identifying these less frequent cases accurately.
Samana, thank you. May you talk about our second challenge and our problems?
Yeah.
Thank you. Which is like,
Please.
our second challenge and our problems are, which is like optimizing assembled bit ABC algorithms. As I mentioned earlier, blending random forest and lattice regression into an effective assemble required careful tuning to ensure both models contributed meaningfully. So adjusting the blending parameter alpha was complex as it required multiple iterations to confirm that the assemble generalized well, particularly for minority classes, and for continuing ensuring that the model performs well across all classes without overfitting. So we don't want to just have overfitting there, and remains a major hurdle. Fine-tuning parameters across both models was essential, as even small adjustments impacted the accuracy of minority class predictions. So for the cross-validation and stability issues, Mahmoud, can you just go through?
Yes, of course. So while we have made strides in model accuracy and stability through cross-validation, our reliance on stratified cross-validation revealed some limitation in capturing diverse data distribution. As you know, we aim to further address this by implementing Monte Carlo simulations, which will run the model across multiple randomized data splits to provide a broader view of performance under various conditions.
Okay,
yeah, someone please continue.
Thank you, Mahmoud, and thank you, Mariam. And as you know, we have had some, achievement, and one of them is about enhanced classification with SMODE and RFE. So with SMODE, we balance the data set significantly, improving logistic regression recall for minority classes like cirrhosis and suspect blood donor. As you know, the logistic regression is tested on a raw data set, not the refined data set. And also RFE confirmed the importance of all 12 features and allowing us to retain comprehensive information for better model prediction. So these steps lead to higher classification accuracy across all classes.
Thank you, Sam. And may I talk about the second achievement, which is optimize assemble with ABC algorithms. Just let me go through this part. And the ABC algorithms yielded a well-balanced assemble model that leveraged both random forest and logistic regression, achieving an accuracy of 94.3%. So this just surpassed individual model performances, especially in minority classes like suspect blood donor, where the F1 score rose from 20% to 50%. This improvement underscores the effectiveness of our assemble approach in identifying hard to classify cases, make it suitable for HCV detection. Mahmoud?
Yeah. The final step is about model stability and preliminary Monte Carlo results. Our cross-validation process has improved model reliability, showing a consistency across folds. As we've been implementing Monte Carlo evaluation, initial results indicate a stable model. We will continue testing with additional data variation to strengthen this foundation.
Thank you, guys. And the last part, I think we have some, plans for the next week.
Yeah.
Yeah,
Can you talk about the plans? Thank you.
Okay.
I'm so sorry, I'm just interrupting you. So I'm gonna talk about our next plans for the next weeks. Our just next plan is to deepen our Monte Carlo simulation to just further assess the model's robustness. By testing on multiple randomized splits, we aim to confirm the assemble's stability across diverse data distributions, which is crucial for generalization and practical clinical application. After completing Monte Carlo evaluation, we wanna just work on our final report and our documentation. We will document our findings, particularly on the role of the ABC algorithm and Monte Carlo in enhancing performance. So this will be included in our final report, providing a comprehensive view of our methodology and results. In parallel, we will prepare a presentation highlighting our achievements and the model's potential for clinical applications. And we are just focusing on performance metrics and how Monte Carlo testing has enhanced reliability. This will support our case for deploying the model in real world scenarios. So thank you guys. Thank you, Professor. For the update, I want to summarize the things that we mentioned and we want to work on them. We are making strong progress with the assembled model and we are improving detection, accuracy, and precision for minority classes, which is very important for us, and like suspect blood donor and hepatitis cases. Our next step are to conduct just Monte Carlo simulation to validate the model's robustness and to finalize our documentation. And we are emphasizing the contributions of the ABC algorithms and smooth balancing in enhancing the model. For any blockers mentioned, let's just tackle them and plan to stay on track. Guys, thank you. If there are no other questions, let's just keep in touch, and we are working just in the couple of next days, and we're checking again at our next meeting. And feel free, just reach out if anything comes up, or if you want to add something, if you want to just ask something, explain something, we are in touch in our group. Thank you, guys. Thank you, Professor.
Thank you.